Myself, G. Revati, working as Assistant Professor in the Department of Electronics and Instrumentation Engineering at Erode Sangundar Engineering College. Today, we are going to see about science of measurements and classification of transducer. Basically, what is meant by measurement? It is the technique that has immense importance over the evolution of the human civilization. When the measurements were first needed to regulate the transfer of goods in a trading system to ensure the exchange was fair. The measurement is generally defined as the measurement of a given system is the art or a result of comparison between the known quantity and a predefined standard. Since two quantities are being compared, the result is expressed in numerical values. The purpose of measurement is to convert the physical parameter to a meaningful number. Whereas standard is defined as the physical personification of the unit of measurement. The device or instrument used for comparing an unknown quantity with the unit of measurement or standard quantity is called as measuring instrument. From the diagram, we can infer that the comparison process takes place by comparing the unknown quantity with the standard quantity or a known quantity. From that comparison, we can obtain the result, that is the measurement of the given quantity. The purpose of carrying out the measurement is to understand an event or an operation and to monitor an event, to control and to collect the data for future analysis and to validate the engineering design. We have two different methods for measuring. They are direct method and indirect method. In the direct measurement method, the unknown quantity is measured directly instead of comparing it with the standard one. Example, we can use ammeter to measure the current, voltmeter to measure the voltage, ohm meter to measure the resistance, and wattmeter to measure the power. Whereas in indirect measurement, the value of unknown quantity is determined by measuring the functionally related quantity and calculating the desired quantity rather than measuring it directly. For example, we can consider measuring the resistance of the given material, in which we have to measure voltage and current rating of the material, so that with the help of the equation R equal to V by I, we can calculate the resistance of the given material. Now we will see the functions of the instruments and measurement system. The instruments are classified upon the functions they perform. There are four main functions performed by them. They are indicating, signal processing, recording, and control. The operation of the measuring instrument could be described in a generalized manner with the help of the functional elements. Each functional element is made up of components which perform required and definite steps in the measurement. The functional elements of the measurement system are primary sensing element, variable conversion element, variable manipulation element, signal conditioning element, data transmission element, data presentation element. This is the block diagram for functional elements of a measurement system. We can infer that it contains physical sensing element connected with variable conversion element, which is then converted with the variable manipulation element. From the output of the variable manipulation element, the data transmission element unit is connected. From data transmission element unit, data storage and playback element unit is connected. Finally, the output is fed to the data presentation element. At last, the observer can view the result in the data presentation element. Now we will see what is the work of each and every element in the blocks. First one is physical sensing element. The quantity to be measured makes its first contact with the primary sensing element. The measurement is thus first detected by the primary sensor or detector. The quantity to be measured is detected with the analogous signal, which is then converted into electrical signal by a device called transducer. A transducer is a device which converts any physical quantity into electrical quantity for the purpose of measurement. In many cases, sensors may be absent, but transducer is a mandatory one. The first stage of measurement system is known as detector transducer stage. The next block is variable conversion element. The output of the primary sensing element may be an electrical signal or any form, such as voltage or frequency or some other electrical parameter. It may be a deflection of elastic membrane or some electrical parameters such as voltage, frequency, etc. Sometimes the output from the sensor is not suited to the measurement system. For the instrument to perform the desired function, it may be necessary to convert this output signal from the sensor to some other suitable form while preserving the information content of the original signal. Some systems do not need any variable conversion element, whereas some need more than one variable conversion element. The next block is variable manipulation element. Variable manipulation element. It means there is a change in the numerical value of the signal. It manipulates the signal presented to it, ensuring that the original nature of the signal is preserved. The manipulations can be linear or non-linear. Linear manipulation can be amplification, attenuation, integration, differentiation, addition or subtraction, whereas the non-linear manipulation can be modulation, deduction, sampling, filtering, chopping or clipping. Depending on the output signal from the transducer, the corresponding manipulation elements can be used. For example, a voltage amplifier acts as a variable manipulation element, in which the amplifier accepts a small voltage signal as input and produces an output signal which is also voltage but of greater magnitude. The variable manipulation element could be either placed after the variable conversion element or it may be precede the variable conversion element. The next block is about signal conditioning element. Signal conditioning element. The output signal of the transducers contain information which is further processed by the system. Many transducers develop usually a voltage or some other kind of electrical signal, and quite often the signal developed is of very low voltages, maybe of the order of millivolt. This signal could be contaminated by unwanted signal like noise due to an extraneous source which may interfere with the original output signal. The solution to these problems is to prevent or remove the signal contamination or distortion. The operations performed on the signal to remove the signal contamination or distortion is called signal conditioning. The next block is data transmission element. There are several situations where the elements of instrument are actually physically separated. In such situation, it becomes necessary to transmit data from one element to another element. It can be wired or wireless as the situation demands. The element that performs this function is called data transmission element. The data conditioning and transmission stages are commonly termed as intermediate stage. Last one is data presentation element. The data presentation element conveys the information about the quantity under measurement to the personal handling of the system. It has to convey the information about the quantity under measurement. The information conveyed must be convenient in nature. In case data is to be monitored, visual display devices are required. These devices may be analog or digital indicating instruments like a meter, voltmeter, etc. In case the data is to be controlled, then microprocessor or microcontroller and computers may be used. Now we will see what are the different types of measurement units available for measuring the parameters. Generally we have different types of units. They are fundamental units and derived units. The fundamental units are known as the fundamental unit measures the length, mass and time. They are the basic fundamental quantities of the other physical quantities. It also mentions certain physical quantities in thermal, electrical and illumination disciplines. They are represented as auxiliary fundamental unit. All other units which can be expressed in terms of fundamental units are derived units. Derived unit means they are derived with the help of the fundamental units. Every derived unit originates from some physical law defining that unit. For example, the unit of length is meter. That is the standard notation or standard unit for length. For mass, it is the standard unit is kilogram. Whereas in derived units, the standard unit of area is derived with the help of length into length, that is meter square. The area is defined, the area's unit standard unit is meter square. A derived unit is recognized by its dimension, which can be defined as the complete algebraic formula for the derived unit. The dimensional formula of the derived units are particularly useful for converting units from one system to the another system. Now we will see what are the different types, what is meant by standard and how it is defined. A standard is the physical representation of unit of the measurement. Depending its function is classified as international standard, primary standard, secondary standard and working standard. The standards are used for the purpose of obtaining values of the physical properties of the other equipment by comparison methods. The first four are the main standards, whereas the next five stands for the substandards. First we will see what is meant by international standard. The international standard represents certain units of measurement to the closest possible accuracy that production and measurement technology allows. For example, the unit of electric current is ampere. It is followed by worldwide. These standards are maintained at International Bureau of Weights and Measures and are not available to ordinary user of measuring instruments for the purpose of comparison or calibration. The next is primary standard. Primary standard are maintained by national standard laboratories in different places of the world. National Bureau of Standards in Washington is responsible for maintenance of the primary standards in North America. Primary standards are not available for use of the outside the national laboratory. The main function of primary standard is the verification and calibration of secondary standards. The primary standards are few in numbers. Primary standard must have the highest possible accuracy, highest stability if there are environmental and other changes. The next one is secondary standard. Secondary standards are the basic reference standards used in the industrial measurement laboratories. These standards are maintained by a particular involved industry and are checked logically against other reference standards in the area. These standards are periodically sent to the National Standard Laboratory for calibration and comparison against the primary standards. The national laboratories send the secondary standard back to the industry with the certification as regards their measured value in terms of primary standard. The next is working standard. Working standard, these are the major tools for measurement laboratories. These standards are used to check and calibrate the instruments in the laboratory. The working standard chosen should be at least 10 times highly accurate than the instruments to be calibrated. The next is current standard. The fundamental unit of electric current is defined by the International System of Units as the constant current, which maintained in two straight parallel conductors of infinite length and negligible circular cross section placed 1 meter apart in vacuum will produce between these conductors a force equal to 2 into 10 power minus 7 Newton per meter. Now we will see about calibration and what is meant by static calibration. Generally, calibration is defined as the act of comparing an unknown quantity with a known quantity of higher accuracy. It is calibration is procedure for determining the errors of the given instrument. The calibration of all instrument is important since it provides us with the opportunity to find errors and accuracy of the instrument. Calibration procedure involves the comparison of a particular instrument with either a primary standard or with a secondary standard with higher accuracy than the instrument to be calibrated or with an instrument of known accuracy. The general rule for selecting a standard instrument against which a test instrument is to be calibrated is that the standard instrument should be at least 10 times more accurate than the test instrument. The calibration of the instrument takes place with the care of full scale, range, output signal, linearity, resolution, cross-axis sensitivity, thermal zero shift, thermal sensitivity shift, etc. The static calibration refers to the situation wherein all the inputs, whether it is desirable or non-desirable, modifying or non-modifying, interfering or non-interfering, are kept at constant values. In general, static calibration is defined as the process in which the measurand is compared with the known standard. The steps involved in calibration are as follows. First, we have to identify all possible inputs of the instrument. Then we have to decide which of the input will be significant for our application. After that, we have to determine the apparatus and methods to control all significant inputs over the desired range. By varying one input and holding the other input constant, we can develop the sensor input and output relation.